Hello guys, how are you doing? This is your Dr. Mandari Shiva. In this video, we are going to cover the toppling problem, which is from rotational dynamics. Let us look at the question. So here, a horizontal force F is applied at the top of an equilateral triangular block having mass m. Okay, this triangular block is having a mass m, and it's a equilateral triangle. So that means all the sides, all the angles will be equal, and all the sides also will be same. Yeah, that's given in the problem itself. Now, the minimum coefficient of friction required to topple the block before the translation will be, you need to find the minimum value of mu, which is the coefficient of friction. Now, what are the forces acting on it? Obviously, applied force. So, whenever there is applied force acting on the system, if there are no other forces, definitely the body will tend to move in that direction. So, that's called relative motion. To oppose this relative motion, there is something called friction here, okay, which will be acting in the opposite direction to this applied force or relative motion. Okay, now if you see what are the other forces acting on the system, that will be mg downwards to one more force, that is in the opposite direction to this mg normal reaction, which will be perpendicular to this surface. Now in this toppling problem, only one thing you need to understand, that is shifting of normal. What is that? Shifting of normal. So what happens is when you are applying the force, initially when there is no force, then the normal reaction will be exactly at the when exactly opposite to this mg, and it will be passing through the center of mass. Now as soon as you are applying the force, then this normal reaction starts moving towards the direction of applied force. And now at the end, when the critical condition where the system or the block starts toppling, in that case what happens, this normal reaction will completely shift towards the toppling point. This will be the normal reaction right now. Okay, now at this location you'll have the toppling to happen. Okay, now so let us understand what is the critical condition here. Critical condition is nothing but beyond which the toppling starts happening. Okay, so the critical condition is nothing but the system is under equilibrium. So again, beyond which the system starts toppling. So the meaning of this equilibrium is nothing but the net force acting on the system will be zero. What does that mean? All the forces acting on the horizontal will be balancing each other. You can say applied force should be balancing the frictional force. Next, all the vertical forces, normal reaction and mg should be balancing each other. Are there any other forces? No. Now let us try to understand what is couple. Here if you see, this applied force and friction are equal in nature. I mean, both of them are same in magnitude and opposite in direction. Two equal and opposite forces acting at a separate, particular distance is nothing but a couple. Okay, so here capital F and small f are forming a couple, and mg and n, normal reaction and gravitational force are also forming the couple. Now couple can be defined as either force acting on system and the perpendicular distance between both the forces. That has to be the product of these two is nothing but couple. Now let us try to apply this. Let us try to equate both the couples that are acting on the system. So if you see, I can take either these forces. Let me take friction times the perpendicular distance between these two forces, F and F. So that is this distance, isn't it, from this location to this location. So if this is A, this will be A sin 60, opposite side will be A sin 60, and the adjacent side should be A cos 60. Now let us take A sin 60 will be the perpendicular distance between the two forces, should be equal to the other couple that is acting on the system, that is either I can take either n or mg. Let me take n, and what is the perpendicular distance between these two? A cos 60, A cos 60. Now let me write A sin 60 is nothing but root 3 by 2, and A cos 60 is nothing but 1 by 2. So A by 2 gets cancelled, and what is the maximum friction that can be acting on the body? That is limiting friction. limiting friction will be mu n, isn't it? So let me take that mu n into root 3 should be is equal to n. This n and that n will be cancelling each other. So root, now you want the mu, right? So mu should be is equal to 1 by root 3. So this is the critical condition. So what did we understand? Beyond this, the toppling starts happening, isn't it? So if you look at this, beyond this, if suppose mu is greater than 1 by root 3, then the toppling starts happening. Understand? Because here, if suppose if F is more than capital F, frictional force is more than capital F, then only this translation motion can be completely blocked, and then this toppling can be started here. Okay, this is the condition. Okay, that is the answer. Now we can also find out the maximum force that is needed to apply for toppling. Okay, what is that? Let us take the same couple information and try to understand. So if I take this force now F, and the perpendicular distance between other forces A sin 60 should be equal to, let me take mg. I have taken earlier normal. Now let me take mg. And what is the perpendicular distance between these two forces? A cos 60. So now this here, that A gets cancelled. So F sin 60 is nothing but root 3 by 2 once again, and mg and cos 60 is nothing but 1 by 2. So these two that gets cancelled. The maximum force that we can apply mg by root 3. Okay, so this is the force we can apply so that the system will be under critical condition. Okay, if you have any doubts, you can comment below. Thank you very much for your kind attention.